Before we have the official concluding remarks, I'll have a few remarks to make about this particular session. I think what you saw is that specifically for Alpha Centauri, the future, the short-term future, talking about 5 years, is very bright because we have multiple ways at detecting and gaining information about potentially habitable planets around Alpha Cent. If we have radial velocity data, if we have astrometric signals, if we have a 10-micron flux detection, we already know a lot about the planet. We know its orbit, we know its mass, we have some idea of its radius and temperature. And then if we look a little bit forward with new capabilities, whether it's a star shade in space or a capable instrument on NELT, we're starting to get even more characterization. We may have UV flux measurements, detecting ozone, spectroscopy in the near infrared, spectroscopy in the visible. So we're really looking at a unique opportunity. We have this star very close to us, this pair of stars actually, where if there is a habitable planet in the foreseeable future, with technologies that are right around the corner, we can actually not only detect it, but understand that it is a very interesting target to visit. And then if Alpha Centauri does not have such a planet, the next generation of facilities, specifically ELTs, but also things we will develop in space. There's also NASA missions that are going to come on the horizon. Will be able to actually detect those planets and also do the same characterization on those planets at about the distance of 10 to 12 light years. So I think the future is very bright for us. We have a lot of work to do.
When I look back at the talks today, we're truly standing at a precipice here. And I know it's easy to say that, but it's amazing to see the depth and the broad range of things that we're planning to do, from looking for signals from perhaps extraterrestrials to visiting nearby exoplanet systems, to really doing extremely high-resolution imaging to be able to see them and look for biosignatures in their atmospheres if they exist, or just looking at atmospheres in general. And I think it's an amazing testimony to the community, not just those present here, but the entire community. And I think I'd like to go back to what was talked about in the beginning, what Avi brought up, that we should keep our minds open to the radical innovations that are surely going to come our way in the next couple decades. And if we lock ourselves in too early, like we do on space missions, where we lock the technology in 20 years before the launch, by the time we get to launch, we often have much better technology that we wish we could have flown. And I think the same will be here. There are new innovations on the horizon, from detectors to telescope technologies to many other elements that we really should keep in mind. So just want to bring to your attention that things are changing extraordinarily rapidly. And what I talked about this morning is this technological evolution which happens on a time scale which is short compared to your time scale. So in one of your lifetimes, let's say you're lucky enough to live 100 years, and we have a folding time, a doubling time of order 1.5 years, that's 60 folding times. That's comparable to inflation in some of the folding that we think about. So, just imagine 2 to the 60 power, which is, 1 million cubed. So just ponder that, if you will, because I don't think we understand the true radical innovations that are in front of us every day. Anyway, I just want to thank you all for a great day. It was a wonderful set of discussions, and I look forward to much more tomorrow, and enjoy the evening tonight. All right, thank you.